Hi, everyone. Thank you for joining us on this webinar. We're going to show how Blokable implemented Mender for secure and robust OTA software updates for scalable housing creation and operations. The hosts of our webinar are going to be Sandy Anuris, VP of Technology at Blokable, and Eystein Stenberg, who's the CTO and co-founder of the Mender project. And with that, Sandy, I'll let you go ahead and take it away.
Thank you, and thank you for having me this morning. So I'd like to tell you a little bit about Blokable first. Blokable's mission is to make quality housing attainable for everyone. We're founded by real estate and technology industry veterans, and we are a self-performing real estate developer that expands prosperity and equity in communities by building high-quality, low-cost connected housing at scale. The housing market is undersupplied by 7.6 million units, and we have an affordable housing crisis in the United States. We are located here in Seattle on the West Coast, and you can see the effects of the housing crisis all along the West Coast. And unfortunately, because of this affordable housing crisis, the most vulnerable populations are affected. And we're seeing this in terms of homelessness and a lack of workforce housing, student housing, and senior housing, and more. And it's leading to a shortage in the missing middle. We believe that housing is at the root of health, wellness, and prosperity. And yet in the United States, housing is unaffordable for those who need it the most, and it contributes to our nation's wealth disparity. At Blokable, we aim to solve this crisis through two innovations: a business innovation and a product innovation. So on the business side, we've reinvented the development process. We have a vertical platform that integrates planning, permitting, siting, design, manufacturing, delivery, and ongoing support into one transparent and easily managed service. In addition to that, we have two different business models to support this. The first one is what we call housing development as a service. And that's where we work with not-for-profit leaders who are trying to solve the affordable housing crisis by providing a fee-based real estate development service for them. So we're turning effectively dirt into a housing community for them for a fixed fee. And on the other side, we have our market rate development, and in that case, we act more as a traditional real estate developer. So our next innovation is our product innovation. We build high quality, low cost connected housing at scale. And so you can think about this like Legos for housing, where we have two different sizes of Lego blocks at this point. So they come together to make multi-story, multi-family buildings so that they can be built easily and predictably and in more of a repeatable way. In addition, we put together this product so that it's net zero energy ready. We try to meet the Indoor Air Plus standards so we can have a healthier living environment. Because again, just because it's low cost does not mean it needs to be low quality. So again, this is like a Legos for housing product. It's flexible. We can build anything from a studio to a 3-bedroom building. And it's built for architectural design flexibility. So just because, again, you're using a standardized product for the core of the building doesn't mean that every single building has to look the same. What's really interesting about this product is that the site massing and designs can be completed in days rather than months. In addition to being faster and less expensive to design and build, we also want it to be a long-term play in terms of operations. So we have a long-term lifespan for these buildings. It's not a temporary housing development. It is a permanent product. We're looking to have this lifespan of multiple decades. Because it's going to last multiple decades, it has to be easy and low cost to operate. And so we integrated BlokSense technology into it for life safety, energy, air quality, and security monitoring and control as well. In addition, we are engineered for the toughest building structural and energy codes. As we're building on the West Coast, California and Oregon and Washington have some of the highest requirements for structural systems that go multi-story. So we're talking pretty extreme codes that we have to meet for seismic and wind load requirements, and also energy systems. So we plan on achieving this by making it repeatable and scalable. And so we're bringing in manufacturing into the real estate construction process. And our hypothesis is if we can maximize how much work is occurring within a factory, we can standardize much better and therefore drive down costs and drive up quality. And so we are trying to perform 95% of the construction process within the factory. Some of our competitors are doing some of the manufacturing in factory, but then they'll flat pack wall panels, for example, and assemble them on site. Whereas we're really trying to do as much as possible in the factory, and on site is just the foundation work, and then finally the assembly and utility hookups of our blockable units, and then applying cladding and roofing at the end. So some of you may be asking, how does technology integrate with construction and manufacturing? And so at Blockable, we have 3 different work streams that we're working on: the configurator, the in-factory technology, and the insights dashboard, all underneath the BlokSense umbrella. And so today we'll be talking about the insights dashboard, which is really going after that ongoing operations and management piece for the Blockable building system. So you can see a screenshot of our insights dashboard here. And really the goal that we're trying to go after is not trying to allow the resident to control their thermostat, or to let them do the typical smart home technology that you might be thinking about. But we actually went after the owner operator of many of these buildings and communities. Many times, we're working with nonprofits where their staffing is always super busy. And so any tools that we can give them to help them have insights into how their buildings are performing and how the safety of their residents is going will be key for them. So here is the dashboard that an owner operator would come to see all of their blockable communities, all of the alerts that are occurring within each community. So for example, in this screenshot, we have a carbon monoxide event happening in one of the homes. And then be able to just see in a quick glance if their communities are okay. And then as you go deeper into the product, you'll get to see more insightful information about energy usage and other key insights that help owner operators control and manage their communities in a healthier way. So here's an example of some historic data. So we want to float data in real time, allow alerts, but we also want to show historic data because there are often times that nonprofits need to report on how their communities are performing. So for example, here's a humidity detector, and so you can actually see that the indoor humidity has been in the good range. But what humidity can show, for example, is if it's in a position where a black mold event could occur if the humidity levels are too high, or if they need to go in and actually get more fresh air into the homes. But we have leak detection as well, because if any of you have ever lived in an apartment complex or a multi-story building, you know that if your upstairs neighbor has a leak, there's a huge problem where the water can come down and damage all of the units below, et cetera. So anytime you can get eyes on a leak quickly or a burst pipe quickly, that is savings, both in terms of the repair costs as well as potential lost revenue for all the units that could be damaged. So we have leak detection, We have eyes on the energy usage, air quality, humidity, temperature, and we are adding additional operational controls as well that we're pretty excited about. So again, it's all about simplified operations and continuous improvement. So being able to know exactly what's going on, be alerted when there's any particular event that happens is really key for the owner and operators of these multi-story, multi-family buildings. And so this in turn reduces, again, lost revenue and, reduces lost revenue and reduces any sort of insurance premiums that they might have to contend with. And so here's a high-level view of our IoT architecture. And so what you can see here is that we have embedded sensors and devices that are wired directly into our proprietary PCBs. We call them our Hydra circuit boards. And then from there, we have a hub that is our single board computer that is pushing all the data up to a cloud-based data store where we have and we have services and a data store that take care of our data storage, manipulation, aggregation, and then we show all of these insights through our insights dashboard. And as you can see here, Mender plays a key role in providing over-the-air firmware updates to our Blockable hub so that we can always maintain the latest and greatest in terms of security updates and also unleashing net new features as we are ready to launch them into production. So that's a little bit about Blockable and what the technology team does, as well as our insights dashboard.
Okay, great, Sandy. Thanks for introducing. So this is Eystein. I'm from Mender side, and I'll walk through a little bit about over-the-air updates part. Very happy to hear about how you're using Mender a bit later in the webinar as well. We'll get back to Sandy a bit later. So thank you so far. And so with Northern Tech, which is the company behind Mender, we have the mission of securing the world's connected devices. Mender is one product we have, and the mission for Mender is to provide a secure and robust over-the-air software update for embedded devices. We have seen this as a key problem of the basically IoT devices that come online, that they have no good way of being updated. There's a lot of reinventing the wheel. So that's when we decided that it's time that somebody provides an open source end-to-end solution to solve this problem of providing secure and robust software updates. And as probably many of you watching here are aware, a key reason why you need to be able to update connected devices is that there will be bugs and vulnerabilities. If you work with software or any kind of technologies, you know this. There's a industry statistic about 1 to 25 bugs per 1,000 lines of code. The variation depends a bit on the QA processes that are implemented, which depends again on what vertical you're in military. You would have probably stronger QA process. Aerospace, you would also hope so, but you can see now with the recent issues around Boeing that there's also problems there. But you also want the ability to deploy new features to the connected devices after they're in the field. So this is the main message, that you must plan for this, that you need to be able to update this in a secure way. And on the right-hand side, you can see some data points around the critical and high severity security bugs in Linux. So if you're using Linux, you would be affected by these. You can see the version numbers on the left axis there. It's pretty small, but you can see this red vulnerabilities, they're critical, and they're spanning maybe 10, 15 versions of Linux until they're actually discovered and patched. So you need a way to actually get those out to the devices as well. And why is this different for embedded than for example, some cloud infrastructure? And why can't we just reuse the way we're doing with, for example, Kubernetes or package-based installations for desktops in the embedded environment? First off, you have to look at what it looks like, right? What's the environment where you're doing all these updates and you have these connected devices? And some key differences is that it's remote. So in Blockable's case, the homes could be spread out across the city, obviously, or across different cities for a home owner operator. And getting to those devices, if there's something critical, can be very expensive. You have to drive around and maintain them. The lifetime is also typically quite long for embedded or IoT devices. Again, in Blockable's case, I don't know what's your life expectancy for a home, but it's definitely more than 10 years, I would assume. So this is kind of,
We're looking for at least 50 years, but from a technology perspective, we'll definitely be refreshing the tech within the homes a little bit more quickly.
Got it. Yeah, exactly. So they get outdated pretty quickly, and you need to support them for a long time, right? And for power, on the power side, many devices have a battery. This is not the case for Blockable, I think, but you could lose power during the update process itself as well. So you need to be able to handle this. Otherwise, you would have to, again, go physically to these distributed locations to fix any issues. And the network can be unreliable. Oftentimes, it's wireless, maybe 3G, 4G, Wi-Fi, or other types of local wireless networks like Bluetooth as well. And these have inherent problems with connectivity, bandwidth, and security. Obviously, you should assume that anyone can observe the communication here. And the standard approach that I'm glad Blockable did not take, or at least many people do this, is that they think it's a simple problem, so why not just write our own over-the-air software update? What we found from our studies, and one of the key reasons we started to work on Mender, was that a lot of people, they invent their own homegrown updater, and this is very time consuming. So it looks easy in the beginning. You just need to copy some files from one place to the other, right, and restart an application. But when you start to look at all the requirements, I'll cover some of them a bit later. The average time to develop an updater was about 6 months before you had something that worked reasonably well. And then, of course, you have maintenance cost on top of that. And this can span into hundreds of thousands of dollars. Obviously, this is probably not something you want to focus on when you're trying to build a core product feature set and get to market. And also, there's some parts of the over-the-air update process that requires quite high degree of expertise in terms of security features, robustness features. You get quickly into bootloaders, atomic updates. So this needs to be handled properly. Otherwise, you will start to see support issues down the road, and you will paint yourself a bit into a corner once you scale up. And of course, it adds more complexity to the product development cycle, which is something that nobody wants. There's already enough to think about here. Lots of moving pieces. So just quickly to go over the key requirements we've found for an over-the-air update manager. After speaking to more than 100 people who have embedded engineers who have done this in the past, robustness was definitely the key requirement. So the device, the house, the hub should always be left operational. You could lose power, there could be human errors. There's one example of it below in the picture. There was a smart locks company. They actually deployed software for their 7 LockState 7i software was deployed to LockState 6i locks. So they deployed a new software to older revision of the locks, and they were not compatible. So the result was that the devices bricked and people couldn't get into their homes, which they had to ship back the locks, I believe, and it would take several weeks, which is not great if you're trying to get in to your home. So this is one example of robustness problem that was not properly thought through. This should be handled by the update manager. You shouldn't allow these kind of problems because human errors will always happen. So some keywords are atomic updates. Either the software is updated fully or not at all, ability to roll back if there are any failure, compatibility checks and sanity checks of the application after you have done the update. Security is obviously a key requirement. As I mentioned, there are a lot of wireless technologies being used. So you get into this communication, key management, and update authenticity problems that need to be solved as well as part of the update process. Let me see. Few more things to cover on the requirement side. It needs also to integrate well with an existing environment. That's what we focus a lot on for Mender. So Blockable might be using one hardware board and one operating system, one type of development process, one CI system. But the updater itself shouldn't enforce any of these constraints. You should be free to choose what you want in terms of development tools and related technology. Easy to get started is a key one as well, because again, you don't have a lot of time once you reach the point where you want to have over-the-air updates as part of your product. And then bandwidth and downtime are also generally lower is better. So there are some things you can do to work on this side as well as the management server, where you want to see the fleet-wide rollout of the updates and the status of the updates, basically. So there's quite a lot of things to cover, as you can see, and this is typically not something that you think about upfront. Once you start the path of developing a homegrown updater, you discover these things along the way, and this is what contributes to the cost and the time that you will spend on this problem. So rather than doing that, what we're advocating is that you obviously should reuse open source solutions to solve this problem. I think I covered most of this already, but it looks easy in the beginning, but the benchmark we have is going to take you 6 months. And you're going to be maintaining this for a long time. Hopefully your product is really successful. And in that case, maintaining this update process over 50 years, maybe 10 different revisions of the product is generally quite expensive and something you want to avoid. I have a quick a pretty comprehensive, I would say, overview of the updater workflow. I won't go through this in detail, but it just shows like the process the updater itself should go through once it's downloading and installing a new update. So Mender, we're focusing on robustness and security. You can see the architecture on the right-hand side here, where we have a server that you can either self-host or you can use hosted Mender, which we host, so you don't have to worry about the uptime and scale requirements. And then you have the devices, and we have a atomic update process with 2 root file system partitions supporting rollback. So you can see the partition layout in the down bottom right, that there are 2 root file systems, and then some other partitions to support the bootloader and the persistent data. And everything is open source. We have hosted Mender, as I mentioned, was where we provide Mender as a service, basically software as a service on the server side. We also have Mender Enterprise, which is a supported version of Mender, and professional services to help with the board integration, which we also helped Blockable with. So some of the differentiators we wanted to highlight is that there's no vendor lock-in, and we have full end-to-end client server. So we have both the management server and the client, a pretty large community and growing that helps with board integrations or contributes new features or any questions or answers you might have. You can also tap into community to get help from. And as I mentioned, we have easy integration as a key focus area, and the web UI. I'll show you some of these features in a demo a bit later. So with that, I think I will turn it to Farshad, who's working in our marketing department, and Sandy.
Yes, thank you, Einstein. Yes, I'm Farshad with Mender Marketing. Hi, Sandy. Thank you for being with us today. Would love to take this opportunity to ask a few questions about your experience, Mender, and why.
Sure. Thanks again for having me.
Great. Would you share a brief description of your use cases with regards to OTA software updates?
Yeah, so it always comes back to the business requirements to me. And so software and technology should always be supporting what the business is trying to accomplish. And again, at Blockable, we're building permanent, affordable housing that is easy to maintain and operate. And given that as a North Star, we really wanted to build a set of features that would be built directly into the home, like wired into the home, that would always stay current in terms of security, as well as the latest and greatest features that we had to offer. And especially since we're working in real estate and housing, there's a lot of privacy and security concerns we want to make sure that we get right. And so we wanted to be able to launch new features when we were ready, and not necessarily when the housing units went out the door. So because of that, and because we felt so strongly from a business perspective that we needed to maintain the latest and greatest in terms of firmware and software, we knew that we had to have an over-the-air solution for our Blockable homes. Yeah.
Great. What challenges did you face when you're thinking about developing and implementing an OTA solution?
You know, it's pretty funny. We never even considered building our own OTA solution. And this was a classic build versus buy question that I was facing as an engineering leader. And it became pretty obvious to my team and me that we should really buy the solution because we are a startup, so we have a relatively small team size. And as you said, we wanted to really focus on building what was proprietary to us and making sure that we were effectively outsourcing to the industry experts for things such as over-the-air updates. So it really made sense for us to search for a vendor because, for example, you touched on this, Einstein, as well. It seems simple. It's just like, oh, it's just getting data from here to here. But some examples of the complexity that we started, that actually gave us pause was around rollback strategies, handling graceful failures, targeting a subset of devices, and things like that. And my worst nightmare was having a bricked problem, just like that remote lock product that you mentioned earlier in one of your slides.
Where did you consider the OTA implementation in your product development cycle? Where does it usually fall, or what's your perspective on that?
Again, for us, since it was a core business requirement, it was something that we were talking about on day one. Operability and maintainability of our blockable units and of the technology that's in it is really core to the hypothesis of this company. So these were probably one features we knew for sure that we wanted to be able to update over the air, unlock new features over the air for our blockable homeowners. That was just super important. And so we knew that we needed to engineer for this solution somehow, either, again, build or buy it. And as we all know, we ended up buying through you guys.
And what options were you searching for when you were designing on an OTA solution?
Again, the key things that Einstein touched on were core for us. So security of the platform was number one. This is people's houses. This is their livelihood. And so, having a secure platform in order to deliver our firmware updates was key. Robustness, so those edge cases that we just didn't want to deal with. Again, bricking was I bricked my home. No one wants to say that. That's a nightmare solution. So robustness and security were key attributes. And then on top of that, we wanted it to be easy to onboard and easy to update. And so that was a key part for us as well as engineers. Again, being a small team, we wanted to make sure that even though we were outsourcing this, that the integration was there. And so the fact that it was open source and has a robust community surrounding Mender was really intriguing for us. Because we are going to have to support this. There is a portion of this that we need to support. And so ease of use, getting started. And then finally, the cost. We did look at a couple of competitors, and Mender, in terms of features, robustness, security, and cost together, made it an easy solution for us to choose.
And why Mender's hosted solution as opposed to some other ones we offer?
Yeah, so again, getting to my core job, it's trying to figure out, do we build or do we buy? And again, with a small team size, minimizing my corp IT and operations footprint is very important to me. And so anything that could be technically outsourced to a third party in a way that is just as high quality as I would ask my team to build to is an easy solution for me. So hosted solution, the price was right, and it takes one more thing off our plates in terms of having to worry about maintaining our infrastructure.
That's great. And would you be able to tell us your experience with Mender's pro services?
Yeah. So when we were just getting started with a proof of concept, it was really easy to get started with Mender with our Raspberry as our single board computer. And so we got started with the Raspberry. We were just making sure from a proof of concept perspective, everything was flowing end to end to our cloud-based data stores, et cetera, fine. But then as we really refined our business requirements, we realized that the Raspberry it's not scalable for our needs. And so we identified a different single board computer that no one had written an integration with to Mender. And so we've reached out to Ralph, actually, and worked with two engineers, Mirza and Drew, and I would love to give them both a shout out. They were both extremely communicative. They did this work to integrate this single board computer onto the Mender platform so that we could work with it seamlessly. And I've worked with several pro services departments before, and the professionalism in which Mender and Mirza and Drew worked and communicated, and then dealt with any follow-up configuration issues that we had. It was a very easy partnership to manage.
That's great. That's great. We're really happy that we were able to help you.
Me too.
And maybe you can tell us a little bit more about how you're using Mender today, deployment frequency, and technical environments that maybe you're using. How are you using it today?
Okay. So we have a production environment. So we do have several homes that are in production today. And so at this point, we're keeping those homes pretty stable, and we push an update maybe once a month just to make sure that we're getting the latest and greatest onto those tech stacks. But within Dev and QA, we're doing active development right now. And so it varies, but it's up to multiple times per day because we're adding devices and sensors to our network and adding functionality right now. And so we are using that multiple times a day. And again, if you you remember the slide that had our IoT architecture on it, we have the single board computer, which is Yocto based, and so that is receiving the updates from Mender. And then we have several proprietary Hydra boards, the PCBs there that are getting proprietary firmware pushed then from the single board computer. And that was actually one thing that was pretty cool that I meant to mention earlier, is that Mender not only met all of the use cases that we had written down that were important for us as a business, we actually found that they had, or you guys had built in several places where there were hooks where we could actually kick off commands or scripts of our own. And what we ended up doing is that there was a hook after commit where we could push out the firmware updates to our Hydra circuit boards as well. And so that was something that we hadn't even considered as a use case that we wanted our OTA updater to be able to do, but you guys could, and so we were able to take advantage of that for our Hydra circuit boards as well.
Thank you so much for that, Sandy. We're certainly happy to have played a role in your success. So, and I'd like to turn it over to Einstein now for a demo presentation. Einstein.
Sure. Thank you, Sandy. It's been interesting to learn about your use cases and your product. So at this point, I'll show you a quick demo of how Mender looks like. So I'll have to switch my screen sharing a little bit here. I'll show you the web interface for Mender. So this is the, I guess you would say, day-to-day area you would work with Mender. After you have integrated the board, turn it on, it will show up here in the management web interface. We also have APIs, obviously, that you can use for all the functionality you can see here. There's a REST API available, so you can integrate this and automate it as you scale up. But it's a nice place to start off if you're new to Mender and to sort of get the concept of what's going on. So if we look at the devices here in this environment, this is a virtual environment, but in Blockable's case, this would be a hub or represent a home. So you can see this that have been connected already, and you can also see some information about them. So this is completely customizable. You can add inventory that's important to your business and your use case. A common case that Blockable also is doing is to have their own dashboard, and you can add inventory to Mender. For example, the kernel, the Linux version you're running, and take that into your customer's dashboard as well, if that's something you want to expose. So you can see that these devices are all on the same image here. And as Sandy mentioned, you can also create subsets of devices. We can create a test environment. And target these devices only in part of the deployment. As part of the workflow, you are generating some output from engineering, hopefully fairly frequently. These are represented as Mender artifacts. So a Mender artifact is simply a package with the software you want to deploy to your devices. So Mender supports basically any kind of format. The most common one we have is the full root file system image. This supports atomic rollback, and it's a very robust approach. But you can also deploy now with Mender 2.0, which was recently released. You can also deploy package-based updates or file-based updates with a trade-off of against robustness, obviously. But we recommend that you at least get to the full image approach down the line so that you can benefit from it. So after you have built your software, you packaged it into the Mender artifact format, which is done automatically. If you're using Yocto, you will get these .mender files as a build output. So it integrates into your build. You can deploy this. So if we have a new release, so let's say it's release 2, you can simply select that. That's what we were just looking at, where you uploaded it. And then I created a test group so you can deploy to that or to all devices. And also note that Mender will check the compatibility of the hardware and the software. So in this case, both the devices in the test group are compatible with this software. So the software comes with a list of compatible device types, as we call them, to avoid the smart lock bricking case as well. After you've done that, you can create the deployment, and now the devices that are targeted for this deployment, in this case there are 2 of them, will check in with the server over HTTPS, REST API, and we'll see if there's a new deployment available. So they will do this regularly, and in the next time they check, they will see that there is one, in fact, available, and this deployment will transition from pending to in progress, as you can see now. So you can follow this was actually quite fast. So it's already installed, and now they're rebooting into the new image. It was successful in about 1 minute. If there's any failure, you lost power during the deployment, you can actually see the log as well here for the failed devices. But again, if it fails, the device will still work. You can do another deployment to it because it will simply roll back to the old version it was running. So as you can see, the 2 devices we were targeting, they now have the new version of the software. And they are in in this test group. So that's a quick introduction to how Mender works. I hope you found that useful. So I'll just unshare my screen here.
Okay, great. So I guess that concludes our session today. And thank you for everyone. Thank you, Sandy, very much for joining us today.
Thank you so much for all your hard work and your time.
Thank you. Thanks, Einstein and Ralph. And that's it. Thank you, guys. Thanks for everyone showing up and watching us today.
All right.
Bye.
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 Bye.